Good morning. This is the Covid-19 Forecasting Project presentation created out of the Code versus COVID Hackathon initiative this weekend. I'm Rui and I'm going to try to present this project. So, what are we willing to achieve here? We're willing to try to attempt to create a forecasting view of how this disease is spreading over the world. Um, Most importantly, this is, of course, a typical severe pandemic model, growing a nonlinear network. I'm sure you're familiar with this type of SEER models. And we're trying here to create a forecast at a more granular level. Why do we think it's important to create that type of forecast? Because we think we should spend time in planning as opposed to reacting. We think that if we have a better demand signal at the local level, we can have a better supply response, supplying goods to hospital, beds when patients need ICU care, teams of doctors, nurses, competent people, all the necessary equipment to actually cure the disease the better that we can. And we think that this forecast at the local hospital level will help prepare better and potentially avoid a global lockdown. Now, the challenges that we face, this virus has no history. It's a new virus, there's no history. It's difficult to actually predict when we don't have history. And this is the very first data that we received. This might be biased. No criticism here, it's just the fact that this is the first data, and of course, when you collect fresh data, initial data tend to be biased. So how can we find history? We just have tons of data available now, provided from a lot of different sources. But interestingly, if we observe the trends on the number of cases, we can then look at what happens inside the hospital. Then we looked inside hospitals, what is the spread of these people inside the hospitals, how many people need intensive care, and unfortunately, out of them, which are the ones who die. So we analyze this data from all countries, collecting various sources, and then adopt a global to local approach from country, region, sub-region, and then hospital. We created tools for that, based out of Python and out of some optimization techniques. We collected then data from local hospital levels and compare the forecast that we created at a more country or even a region level. For example, here in Paris, we have forecasted data out of the region and then compared then the data which is disaggregated at the local level and they match. We then had results that we looked over all the countries, and then compared these results to the curves that we got in reality, and they match at 90 to 95% level. So it's quite a decent forecast accuracy for this first attempt. So now what we would like to do next is probably try to see how we can disaggregate this forecast to country to region and then look at how we can find a better forecast at the hospital level, then project what is needed for them to cure this disease in terms of doctors, nurses, beds, etc., all the means necessary to actually fix the problem. And then maybe use machine learning techniques to simulate propagation, how this disease is spreading into a dynamic network, and of course, with the aim of reducing our forecast error. That's it. Thank you.